fun.
Yeah. It's been fun to have to dig out the book of the movie again and again.
No, I haven't seen it in a long time now. You up first?
I have no idea.
Okay.
Answer questions when asked.
Excellent. Thank you very much, everybody, for coming back for the panel after The Martian. I hope you all enjoyed the movie. Even though I've seen it, I think, twice, 3 times in recent weeks, it still makes me well up at the end when they rescue him. So we hope you enjoyed a truly excellent movie this afternoon, and you're enjoying the first ever Physics on Film event. So now we are extremely fortunate to have an excellent panel to discuss the movie and to answer your questions. So I'm going to introduce the panel. They're going to have each 5 minutes to introduce themselves, talk about their work and their interests, and then we will open the floor to questions. In the movie that you'd like to find out more about, we encourage you to ask the questions. So we're going to start with Libby Jackson, who's joining us. She is head of space at the Science Museum. We're going to have a lot of cool job titles in the introduction. Head of space is one of the best. Although she's 6 weeks you've been at the Science Museum. So before that, she was head of space exploration at the UK Space Agency. Also excellent job title. And also before that worked in mission control at the European Space Agency. So really excellent expert on space exploration. So after Libby, we're going to have our visual effects supervisors talking about their experience working on The Martian. So we have James Fleming, who's the founder of Ombrium, a VFX studio formed a decade ago, which has worked with Paramount, Lucasfilm, Disney, Sony Pictures, Amazon and MGM Studios. Has worked on the Oscar and Bafta winning film Gravity and also on The Martian. For Richard Stammers, who I believe is also in the audience. Yeah, hello Richard. Any difficult questions, we'll direct them to you. Who was Production VFX Supervisor for Director Ridley Scott on The Martian. We also are very privileged to have Chris Lawrence here, another VFX supervisor who worked on The Martian. He's won an Oscar for Gravity and has been nominated for a further 3 Academy Awards. His work has taken him all over the cosmos. He's worked in close collaborations with the likes of Mark Foster, George Clooney, John Krasinski, and Her Majesty Queen Elizabeth II. So I think we definitely need a question about that. Also, we have Matt Sloan, who worked on The Martian as well. So in his bio, these are his words, he spent the last 30 years spitting in the face of physics in the name of cheap Hollywood thrills. So definitely ask questions about that. He's a special effects artist and visual effects supervisor. He's worked on over 55 productions, including the Matrix trilogy, Avatar, The Martian, Prometheus, The Predator, and 2 X-Men movies. Also something to ask a question about is wielding a lightsaber in Star Wars Attack of the Clones and dying horribly in Star Wars Revenge of the Sith. And then finally, to complete this amazing panel, we have Professor Oliver Shortall from Cambridge University, who's Professor of Natural Philosophy at the University of Cambridge's Institute of Astronomy and Department of Earth Sciences. And I just asked him what his job, what he's working on, what his job was, and he said it's to find aliens. So also pretty cool job. So we have an excellent panel. I'm going to stop talking and I'm going to hand over to Libby to introduce herself and her experience. Thank you very much, Libby.
Thank you so much. Yeah, you can hear me back. So yeah, thanks for having me. I'm Libby Jackson. I'm newly minted head of space at the Science Museum and was, as you said, at the UK Space Agency where I was head of space exploration. So today, really I have a brand new role, and my job at the Science Museum is to make sure that our space offering is fantastic. I should say that the Space Gallery, that I am certain everybody, because we're in London, has probably been to multiple times, that we've all known and loved over the last 40 years, has started to close. The first part of it closed on Thursday, and the second part is closing in about 3 weeks' time. So if you haven't gone and said your goodbyes to that gallery yet, maybe you want to pop down there later today or in the coming weeks. It's free, it's fabulous. But we're closing it because we are renovating that gallery downstairs. It will be opening again in a couple of years' time as the Tomorrow Gallery, which is really relevant for what we're talking about today, because the science in that is really looking into the future, into the exciting science discoveries of tomorrow, and it will include a part of the James Webb Space Telescope, which I know Ollie will be talking about in a little while. But my role at the Science Museum is to make sure that our space content right across the group in all of our museums, there's the Science Museum, we've got National Railway Museum, Locomotion, the Media Museum in Bradford, Science and Industry Museum in Manchester, is fabulous. I'm delighted to be doing that. And we're looking ahead, we have ambitions for the future. And so I will be bringing all of that to make sure that we keep using space to really inspire everyone to see how fabulous science and technology is. But as I say, this is a new role for me. I was at the Space Agency, left there at the end of the last year. And my team there was responsible for all of the missions and the UK's activities in missions to the Moon, to Mars, and to the International Space Station. So I spent 11 years at the Space Agency. Started out by managing the education programme for Tim Peake's flight, which was fantastic, and then moved into managing the science and then all of those missions that we do. And the UK has a fantastic place in space exploration. We have companies here in the UK who are contributing to missions to the Moon, to missions to Mars, to experiments and technology on the International Space Station. We have world-leading scientists in that. And perhaps sometimes people are surprised by just how little of your taxpayers' money goes towards making sure that the UK has roles in these. It's about £1.50 a year, something like that, which gets us involved in all of these missions. It allows us to have crew flying to the space station. It has world-leading Mars scientists. We have a UK-built Mars rover called Rosalind Franklin that will be launching in 2028 and is going to look for signs of life on Mars, which is all very relevant to what we're going to be talking about, delighted to say. And then if you go right back, my dream as a child was to work in mission control, and I was really lucky enough to do that. I was a flight controller and then a flight director for the International Space Station at Europe's International Space Station Control Centre. So I have a lot of thoughts and views on what we saw from the mission control elements of this as well as the Mars parts. Generally good, but I think my overall view of the film is that they had a Hollywood budget, and believe me, in the space circles, we'd love to have the budgets that would allow things on the scale that we saw in the movie. But that truly was a dream job, and absolutely fabulous and fascinating. So to end up here talking to the people who have made all of those things come to life, to allow people to see what it's like and to keep inspiring them is all really fun, and I'm really delighted to be here. So thank you very much.
I've got slides to show. So James, do you want to?
Yeah, sure. We've tested this earlier, so hopefully there won't be any technical slowdowns now. Let's see.
We have an interview where we can look up some technology.
Just brought some slides today to show you, just to see a little bit how the movie works. Hopefully this will all work as well as it did earlier. Yeah, just while this is loading, my name's James Fleming, in case from earlier. VFX Supervisor, and I'm the founder of a company set up a decade ago on VFX. We last worked with Ridley Scott recently, actually, after this, when we worked with him on Gladiator 2, which was super fun, doing a lot of that big spectacle that's just come out recently. Just going to load in here. So yeah, then since way before then, we worked on this, 10 years ago, but I was working for a different company as an individual then, rather than this one. I was working at Twickenham Film Studios. And Richard, who is the big head honcho, he was the supervisor who came to us, and he said, we've got this big amazing movie we want to work on, and we want to split the film up into different areas. So we were asked to look after all of Earth, and then like Chris was asked to look after space, and Matt was looking after all the shoot across the show. I've just got these now. Let's see if this is working. Okay. Open the wrong thing, so it looks silly. Right, okay. So, yeah, just to start off, I've got, let's see if the internet works. This is what you would have seen in the movie. So you've got, this is NASA in the future. That was the challenge that they wanted to say, you know, what was it going to look like? We were trying to imagine that. Oh, yeah, thanks. Let's see. Well, I'm just going to, just before using the laser, I'm just going to see if this trailer will work. So this is, you would have seen this from the beginning, this is top right-hand corner is Corda Studios. So we went out to meet with Richard in Budapest, in Hungary, and these were the films that we worked on. I'm going to go into a little bit about this, but bottom right-hand corner is a shot I'm just going to play, which you would have seen in the movie, but just as a reminder, that's the entrance to NASA. Let's see if I can get that to play. So trailer should be good if the Wi-Fi is still connected. Okay, so this was the first trailer that came out for The Martian. I'm just going to play, I'll play it a couple of times because it'll be so quick, but the very first one that comes out is the opening shot. Don't know if there's sound, but we'll find out. That's the one you would have seen. So we had
basic instinct to help each other out. If a hiker...
Play that one more time, just because it's very quick. I'll explain this, so you'll see it one more time.
Every human being has a basic instinct to help each other.
And nicely it follows on to the interior of the building I'm about to speak to. So back to the image, so now you know you've got some bearings on what I'm going to talk about. So this will pop back up. Yeah, so Richard came to us with this idea, we have to make NASA in the future. What could that look like? It was his vision. He had this really clear plan of, one of the things they said, if you can see my mouse, hopefully, yeah, you can, great. So it saves me the laser. Okay, so they wanted to say, let's make this all of NASA, and this front here was the Corda gates. So as you can see, we kept this in the front here, but we wanted to actually build all these buildings in 3D behind and sit all around this sort of area here. All the front was replaced, almost everything in the shot was completely. He wanted a nice guy. It was a boring, dull day, and we had to make something, really pretty. And this building here was an important one. This was where they are in the movie a lot of the time. That's where they're having all these conversations. And that was a building that we went to in Budapest, which was called the Whale in English. I think it was called Balna or something similar. And we had to not just build this as one image. It's not just that we had to build it so they would work at night, because this was a very complex scene where they only had a few extras, and we had to build digital double people, add in the screens to say what the story was going on at the time, all these things. And we're now going to go through, so we had to use this to build these two. Then we had this part here, which was put into this area down here. And now I'm just going to take you on the next slide inside the building for a lot of the other stuff. So we're looking over all of the Earth type shots. Again, inside here, this was the actual building inside the Whale. It was like a conference center. We had to go around and take lots of still references, pictures and things. And Richard wanted one of the rockets that was one of the old rockets, almost like a museum piece that had to go on the top. And through the movie, you'll see them as they're walking around. It's attached, hanging to the ceiling there. And this is just a reference of what the Whale looks like from the top. And then just moving on to, just the last thing is just to move on to pass on to the next guys. This is just a couple of little examples of other random things. So we had to look after China. So we recreated this. It was using a different conference center. We were just putting on Chinese writing. We had to build this whole digital double crowd, snow. Bottom right here is Trafalgar Square, which they managed to shoot during the day. So we do something called day for night, where they have to turn the day shot into a night shot, and then we have to build all the people. They weren't there. These big jumbotrons, they were called, people in the windows, etc., etc. And down here, this was something I was on set with Matt. Was that they had a few of these little gravestones for Watney, and we had to go there and measure out one of these little gravestones and use something called photogrammetry, where you take pictures of it from all different angles. We had to replicate this to look like there were tons of them. And just to finish up, because we were part of Earth, sometimes the companies have to cross over. We were doing a lot of the graphics throughout the movie, so you can see at the top right, what day it was on Seoul Day. And we would receive from the other companies, so we wouldn't do the outside, that'd be a green screen, and we'd have to take the outside from the other companies, put it in there, make it look like he's actually there, and then all that stuff from space onwards is over in Chris's bag. So I'll end there and escape from this place. Well, thank you for your time. Thanks.
Thanks, everybody. So my name's Chris Lawrence. My middle name is Cosmo, and my father was a physicist, so I think I was sort of at some level born to do this. I was brought up in London. And actually, having just heard that the gallery at the Science Museum is closing, was really knocked me off my stride, because that was definitely a kind of huge thing for me growing up, was going there and seeing all those amazing things. But I think that there's a really interesting vein to sort of mine there around science communication and what that means and where it's going in the future. So I'm hoping we can kind of explore that. I've had 2 really, really good days at work. One was when I won an Oscar for doing Gravity, which I couldn't quite believe, and getting to go to the Academy Awards. And the other, which was, I think, slightly better, was standing with Matt at JPL in Pasadena and telling them how to build spaceships. Because that was just beyond the kind of hopes and dreams of anything I could have grown up imagining I was going to do. And I think that it was kind of facilitated by this production and by these kind of... when we did Gravity, we didn't have any NASA cooperation. They didn't want to show the International Space Station being blown to bits. And so we were kind of working on our own. Whereas this was the other way around, where JPL and NASA really wanted to be involved, and they kind of helped us. And while we were working on the film, we tried to sort of repay the favour a bit. And I was going to show a little bit, just because I thought it might be kind of good context. But we sort of tried to be very authentic. Visual effects is about, it's really, you're trying to create a magic trick. I don't know that you get to truly be visual effects if you can easily see how it was done. And so authenticity, if you're creating something from scratch, is really important. And our approach to this, we did all of these kind of shots of Mars from space, and Richard and Matt were dealing with Mars kind of when we were actually on Mars. And we had a huge problem, which is we didn't actually know what colour Mars was. There's loads of data out there, and I'm hoping maybe Oliver can help us out with this, but there's loads of data out there, but of course, because for science you capture things in different spectra and different properties, and you've got very specific things, but actually if you go out and try and find images that look like what Mars should look like, it's not trivial. And we ended up sort of doing a combination of taking some of that scientific data, these different sources, and sort of and rectifying it together and using some higher res bits and some artistic license, and sort of putting that together to make these kind of epic Martian landscapes, which were based in theory on realism. And I think that's a big theme for us in visual effects, is to sort of try and make it just about real enough. It's a bit like a scientific hypothesis. It's like you hypothesize something and then you prove it. And for us, the proof is whether everybody goes, oh, that was rubbish. And so hopefully they don't. And I think one very gratifying things with The Martian was that, for the most part, that we didn't get too much abuse from the scientific community. Although I did apologise to them for the whole sort of guiding with his hand thing. It was all Ridley Scott's fault. So yes. I just wanted to sort of touch on that as being a sort of, I don't know, that's what we're about really in visual effects, in which we're constantly striving for realism and authenticity, whether that's in a character's performance or a kind of, a Martian landscape. And, we come up with all sorts of challenges. I think the hardest thing was probably just getting away from gravity. And, you obviously can't kind of, sorry, I'm going to skip. You can't escape gravity here on Earth. And so if you're filming and you're trying to remove it, it's fantastically difficult. And I think that's kind of probably a good moment to segue to Matt, who can talk a bit about these kind of sets and the stuff we did. Do you want to
sure.
Yeah. Come on.
I'll do it from here, but yeah, I don't have any materials, sorry. But Matt Sloan was the on-set supervisor on The Martian. So my job was dealing with Ridley, mainly, and trying to work out how we were going to shoot different elements for these different shots. Again, as Chris said very astutely, you can't escape gravity. That was our worst enemy, trying to shoot on set. With all the wire work, is trying to work out how to hang the people, not have them. I know there are a couple of shots in there where people are changing directions. That wasn't my fault. I didn't mention it. I was outvoted. But we had people hanging upside down, we had people hanging vertically, would flip the set upside down and then hang them upside down themselves and then flip the camera upside down. Just so people weren't aware, you can feel the gravity, but sometimes if it's in a different direction, you won't feel it as much. It's just enough to fool people, enough to get through the 3 seconds into the next shot. So there's a lot of arranging for that. Similarly, when Mark's in the tumbling capsule, the capsule was 8 meters wide. That's the other thing, is we can justify anything behind the scenes. We can talk about it and be like, I mean, if it's sort of like one of the catches just sort of hooked up, that would just sort of kick it and it would just start gently rolling there. And sometimes Ridley would be like, I don't care, just give me something for the behind the scenes. And it's like, okay. But yeah, so he wanted the capsule tumbling, so he's getting a tumbling capsule, but we couldn't tumble the capsule. So we ended up using a friend of ours, Casey Schatz, who did a lot of our previs and layout, working out camera positions and where people needed to be on the stage to get the stuff to work. We ended up with it, so the capsule was static, and he would end up taking a previs shot and then basically locking the capsule down, and you just watch where the lights and camera go. And then we would have big cranes come in, moving the lights, moving the cameras, rotating around, whereas in the shot, it's camera's still and the capsule looks like it's
What's our
rotating.
intercept range?
What are you doing, Chris?
I'm just showing the previous. There you go.
Look at that. So yeah, my job was mainly working on all that. We talked about the physics of the gravity of Mars being 1/3. We toyed with the idea of having some shots where we're actually off angle, building a set on an angle so that when they were suspended from the roof, they could jump slightly higher. But that just turned out for the amount of action we had on Mars, that just was financially unviable. So we did do things. We changed the frame rate of the cameras so that we could just sort of segue into slow motion a little bit every now and then if we needed to. We didn't use that as much as we thought we were going to have to. Because the thing is, as soon as people sort of got the idea they're sold they're on Mars, you could get away with a lot more once you had people already believing it. But yeah, that was basically, that's my job.
Cool. Well, thanks so much. It's a real privilege and joy to be here talking about a film I love and a planet which has a sort of kind of impossible draw on my curiosity as a scientist. So yeah, Oliver Shortall, Professor of Natural Philosophy at University of Cambridge, regrettably not a botanist, but yeah, maybe one day I can study for that. I wanted to start with this really, kind of hauntingly beautiful time lapse, which is just before sunrise on Mars, taken by the Perseverance rover, and it's showing clouds moving across the Martian sky, and it looks, enormously Earth-like. This image, we could be sitting on Earth just about to see sunrise with the light catching the underside of these high-altitude clouds. On Mars, these clouds are most likely made of crystalline carbon dioxide, not water. But I think this kind of time-lapse for me says something about what we're looking for when we explore Mars, whether it's with rovers, whether it's from Earth with telescopes, or whether it's in our computers trying to simulate what conditions might be like on Mars now or in the past. I think in a way what we're looking for is actually Earth itself, albeit beyond Earth. So when we step out onto the surface of Mars, despite how Earth-like that initial shot seemed, we very quickly realize we're in an incredibly alien environment. And this is a really spectacular image taken in 2015 from NASA's Curiosity rover, looking down the flanks of a 100-kilometer across impact crater on the surface of Mars. And off to the left in this image, a mountain is rising, Mount Sharp, that rises over 5 kilometers above the baseline of this crater. And this picture captures something really profound about the history of Mars. And if any of you have taken any geology classes or kind of wandered around looked at the cliffs at the south coast of Britain, you might recognize some familiar features in the foreground here, which is kind of like these little layers, these thin layers of rock stacked upon each other, just dipping away from us towards the center of this crater. Those are fine sediments deposited by an ancient lake that existed probably 3 billion years ago on the surface of Mars. So from those early kind of fuzzy images in the early 20th century, or with the advent of telescopes that ultimately initially drew people and human curiosity in Mars, we now find ourselves with these spectacular images confirming that indeed Mars did have a wet past, and it's beautifully evident for us here in these images taken by the rovers. But the present of Mars, as the film so kind of beautifully emphasizes, is hugely hostile. So the modern Mars atmosphere is dominantly made of carbon dioxide. It's over 90% carbon dioxide, which, as we all know, has a greenhouse warming effect, but nonetheless on Mars, that still leaves the surface of the planet with an average temperature of minus 60 degrees. And part of the reason for that is how thin this nearly pure CO2 atmosphere is. It's 6,000th the pressure of Earth's atmosphere. So it's incredibly, incredibly thin today. But if we could have gone back in time to this same crater, this is Gale crater on Mars, we would have seen something like this. The crater with its central peak, that's Mount Sharp, largely submerged now 3 billion years ago by the kind of more humid and wet conditions on early Mars. So just to look quickly at the timeline of Mars, and we can kind of put Matt Damon in for reference here on the right. He unfortunately arrived about 3 billion years too late to have an easy ride of it. So these features on Mars that we still see today, preserved in the landscape, evidence of its kind of watery past, ceased about 3 billion years ago. And since then, the planet's been largely dry. In terms of my research, I'm asking the question of not only is there life on planets in the solar system, but also beyond the solar system, in the now many thousands of planets we've discovered around other stars. But in doing that, my research is rooted in our understanding of the Earth. And you could see from the film how connected that the team were to Earth and dependent upon it. And in a sense, kind of my intellectual journey beyond Earth, whether it be to Mars, Venus, or exoplanets, is still rooted in Earth. And this image, for me, captures it beautifully. It's a now older image from NASA exploration of Mars from 2004. It's the Spirit rover looking towards the night sky, and there hanging in the night sky is Earth. So at the heart of this journey beyond Earth is, in fact, Earth itself and our understanding of it. Thanks.
Right, well, thank you very much for those introductions. Is this in the way for everyone over here? Should we move it? Okay. Okay. Well, while I move it, I'm going to use my privilege of host of the panel to ask the first question. And then I promise to open it up to the floor. I was interested to know what you think the biggest problems we have to science the sugar out of in order to get to Mars. What are the things that still problems we have to solve?
I could start with that. The two big things, one of which I think the film and the book got, and the other of which I think Andy Weir has said he just put one line in to get rid of, is propulsion and radiation. And so today, to get anything to and from Mars, our rocket's just going to take a really long time. Mars is a long way away. Currently, with current technology, a one-way trip is about 9 months. And then you have to stay for a month or a year, and then it's 9 months home. And you have to take everything with you. And you saw in the film, the MAV, all the supplies that they had. And my general view was that it was a very well-supplied mission. They had a couple of nice rovers. They were staying there for a month. They had an awful lot of stuff that was, set in the future. But we need to solve that propulsion technology, and that's why the Hermes in the book and the film is propelled by electric propulsion, which allows you to have very gentle but very long acceleration, so you can just sort of puff on it and slowly get much faster, and then you have to decelerate very slowly. But we're also looking at nuclear propulsion. if we can solve nuclear propulsion, and I think the electric propulsion in the Hermes is nuclear powered, and you heard about the reactor room, we may get to solve that. But to survive outside of the protection of the Earth's magnetic fields, out in the cosmic radiation is really hard. One day out in space, on the moon, on Mars, is equivalent to about a year's worth of radiation that we receive on Earth. And the trip, the one-way trip of 9 months with our current technologies to Mars would expose an astronaut to their entire career's worth of what is deemed to be acceptable radiation. And so that's I think it's 60% for 9 months. It will be too much for one current trip. Mars doesn't have a magnetic field. So the constant stream of cosmic and solar radiation is bombarding you. It would bombard everybody there. Your kidneys, actually, the thing that are most likely to give out first with all that radiation. But also all of your electronic equipment might get frazzled. Your bit flips would be all over the place. So we really, really have to solve the radiation shielding. And actually the third one, which again, the book and the film touch on, but quite rightly for purposes of storytelling soon disappear from, is the isolation and the fact that you will be out of direct communication with Earth the entire trip. The one-way light travel time when Earth and Mars are at their closest is 4 minutes. At their most distant, it's about 24 minutes. So you cannot have a conversation. It's why everything is in text and it's great, but you're still waiting for these things. And the isolation, dealing with that with the mission control team who will be just not able to help you in real time, that's a huge psychological and technological hurdle that we've got to overcome. But we are working on them, and that's why we're going to send humans back to the moon in coming years, and I am confident we will see humans on Mars in my lifetime, at least, is a prediction.
That's exciting. Thank you very much. Okay, so I'd now like to open the floor. Does anybody have any questions?
How long would he have had to be rocket Iron Man before he ran out of gas?
Let's see. I don't know, and this is the joy of the film was that it took some of the elements from the book, which were sort of nods to, if it was Hollywood, this would happen, and then Hollywood took it and made it happen.
Took it and ran with it, yeah.
Yeah, it was great, but.
I think in terms of mass, to have had enough propulsion coming from that, I can't remember the distance he had to travel, but it didn't feel entirely plausible to me.
The control of it. I mean, he would have never ever have made the jump like that. It was all over the place. And honestly, back to the rotating spacecraft, it was entirely plausible that the disconnection between the booster and the capsule could have caused a tumble. But having caused that tumble, he would then have been catapulted out of it, also tumbling in the wrong space. And that was the bit I went, oh, come on, the physics of this is just wrong. And didn't need to happen. But had he have punctured the hole, it would have lasted a little bit. It would have depended on the supplies in the backpack. But honestly, he was in an EMU suit. And those EMU suits, which look very suspiciously similar to the EMU suits that astronauts wear on the space station today, they have some rocket propellant to control themselves in case they get separated from the space station. The monkey swinging spacewalking was something that looked great on camera, but I sat at it and went, oh, the poor astronauts, because if they missed, they were going to end up in the middle of space.
I was thinking that. With the tumbling, wasn't he strapped in then?
But when he had to then jump out to do his Iron Man thing, he'd have been all over the place and had no hope of ever getting back.
I think I said on set at the day, when he first punctures it and goes out of control inside, I pretty much said, that's it.
It had hit
Wouldn't hear from him again.
No.
Also, their calculation seems to be way off, because they calculate to take all this weight out, you'll get to the desired velocity, and then they use weight.
But no one had ever strapped a HAB canvas to it before. I had some sympathy for them, but the aerodynamics were perhaps not quite what they were expecting. But actually, I have to say, and this is to me the biggest conceit of the book and the film, which it acknowledges by the end, because you say in the film about the air resistance not being needed, so you could strap the HAB canvas on. The dust storm that happens at the beginning of the film just would never happen. Yeah. The air pressure on Mars, as you said, Ollie, was about 1 100th, 1000th.
Yeah, is it 100th?
Yes. So you get to something like 100 miles an hour, but with the pressure, it's a light breeze. It's probably about as windy outside today as it would ever get on Mars, which was why the HAB canvas worked, but you'd have never have stranded him in the first place. But if you hadn't have stranded him, we wouldn't have had the whole story, and it was a good story.
I think Andy Weir spoke to that online at the time and sort of said that he wanted to make it the inciting incident to really be nature against mankind. So I think that was a very deliberate mistake.
Yes, and I have to say, I thought it was brilliantly produced and from the visual effects and so on.
It's actually in the making of DVD, they actually mentioned the storm as one thing they know they had to tweak.
Yeah.
In the making of, on the DVD, if you have the DVD, there's a making of section, and they talk about the storm actually saying that they know that was one of the things they had to just to make the story better. But they knew about it. It wasn't like they didn't realise. Yeah.
I spent almost all my time before coming here thinking how to fix that. How can we still turn nature against Matt Damon? And I think what we've discovered with the seismometer they landed on Mars is that there are Mars.
British built seismometer, by the way.
There's still earthquakes on Mars, so I wondered whether actually the contrivance required was a volcanic eruption. Suddenly, Mars reawakens, and there's a dust storm and a lava flow threatening the safety of the craft.
I think Ollie has just secured his next job as a consultant scientist.
We can save it. I feel we can save this.
And also production accounting, want to talk to you? Without ambition.
Right, we have another question at the back, please.
Barbecues that have been found, and if you found entrances or how to, best ways to look for them, and whether they're going to put a better helicopter on Mars so it can travel a bit further, stuff like that.
So I can say something about lava. Lava tubes on Earth also form. You kind of frequently see it in volcanic eruptions. You get the kind of cold crust that develops, and the lava keeps flowing underneath it. And then when the eruption subsides, the hot lava flows out, and you're left with this natural cave with an entrance. And so they've been thought about as kind of natural habitations on Mars, that once you can get yourself into one of those, you're putting rock between you and the radiation environment of space, which the atmospheres on Mars is not doing enough to shield you from because it's so thin. So the first thing you want to do is get yourself underground, and there's these preformed lava tubes, and that relates back to Mars's ancient volcanic history. So the period in which it was wet, maybe up to about 3.5 billion years ago, is also the period in which it was volcanically active. And I think the film had an absolutely beautiful shot towards the end of like a spectacular volcano on Mars. And it has the largest volcanoes in the solar system, evidencing its kind of volcanic history. Yeah, that's a good question. Yeah. So in terms of finding the lava tubes, then you can do a lot of reconnaissance of the surface from satellite, because the lavas will have characteristic compositions and characteristic kind of morphologies and shapes, and so you could definitely aim to land in an area is a lava field. I think in terms of the present search. The present exploration of Mars, it's rooted in the reconstruction of past environments, and so past environments that may have had liquid water. And so that's probably pushed our robotic exploration into settings where we think there might have been previous lakes or riverbeds, and away from purely volcanic settings. But in principle, we know enough to point ourselves at the volcanoes and try and use them.
In terms of a better flyer.
I'm not going to.
Thick enough to...
Well, the engine, so for anyone who doesn't know, the current rover, NASA's rover called Perseverance, which is trundling around Mars, getting rocks that have very tantalising signs of life, which we'd really like to bring back to the Earth so we can study them, and we'll see if budgets allow. But attached to that was a little technical demonstrator helicopter called Ingenuity. And there were a lot of people who thought Ingenuity was never going to work, and even the engineers sort of thought, I might manage a flight or two. And so the helicopter on Mars. And we were saying the pressure is much, much lower, the air is thinner. To fly a kite, you need a lot more wind. It's just different aerodynamics. So that helicopter is really clever because it has much thinner air to spin its rotors in and still generate the lift to fly. But it worked. And it really transformed how we were able to plan missions, because a rover on Mars, which has to be controlled, and it has some autonomous navigation, but it has to be controlled by people back on Earth, and that delay I mentioned. The helicopter can go and scout. So we could go and fly and see what was ahead, and then you could plan where your rover went. And it's been hugely successful, and so successful that a lot of the engineers are now thinking we will use helicopters a lot more in the future. In fact, if we do go and collect those samples, we may have helicopters go grab the sample tubes and bring them back. So there is more technology being developed for those helicopters. But can I ask a question of the panel? Because I really want to know where Mars is and how you transformed Earth into Mars, because it clearly wasn't all filmed on Mars.
Budapest.
Yeah.
All the stuff around the hab environment was on a massive, massive soundstage in Budapest, where we had the hab and probably 100 meters of dirt around it in one direction. And then for the big exterior stuff was Jordan. So down near Wadi Rum, the southern Jordan. That's where we shot most of that stuff out.
It was a very impressive version of Mars. I thought it was very beautiful.
Oh, it was beautiful down there. Yeah. The environment helps a lot. I mean, it's the go-to for Mars. You'll see Jordan pop up. Wadi Rum, that area, is a traditional Martian landscape. I think people might get to Mars and be disappointed.
Let's go there instead. I think it might not easier. Any other questions?
Bringing rock samples back from Mars and looking for signs of life. How would you do that without contaminating them with stuff from the Earth?
It's an excellent question, and something the UK is working on. So, it's really also really relevant to would we ever send humans there? We think that Mars was a very similar planet to Earth many years ago, and Ollie can speak to life and how it all evolved. But the Mars sample return mission, which is currently hanging by a thread thanks to all the budget reviews, but if it does happen, what we will do is take those samples and completely isolate the Martian environment from the Earth environment and capture it, because we don't ever want Mars and Earth to meet. We don't want to get those samples back and find life or evidence of life and then go, but it's Earth life, because that's a really expensive waste of a mission to contaminate it. And nor do we want to, whatever the risks are, have Mars life, Mars environment interact with Earth environment and potentially contaminate Earth. So at the University of Leicester, there is a technology being developed. It's called a double wall isolator. And it takes the technology that we know, and you may have seen, if you remember back some years ago, there was some Ebola outbreaks, and you see Ebola patients and they're in these really biohazard contained environments because you don't want the Ebola to get out. We're going to do that two ways. And it's the same technologies that are being used. So we are developing that here. So when hopefully these samples return, they will be in these double-walled isolators and allow scientists like Ollie to remotely interact with the Martian rocks to study them. We may then sterilise them more to allow them to come out further. But you should speak a little bit about life, perhaps.
Yeah, so I think Mars is, we can't get an answer to the question of whether there was or is life on Mars that's not enormously informative. So this history of water on Mars, although it may have extended for several 100 million years, possibly only represents in total, if you add up all the moments when there was flowing water, could only together maybe be a few million years. So it may have had a long history, but actually punctuated by mostly being cold. And so this presents a fascinating answer to a question, which is just how hard is it to get life going? Is it enough just to have kind of water on a rocky planet and life will emerge? And we don't know the answer to that. And it may be no, and our exploration of Mars and these rocks may turn back an answer which is negative, which tells us something then really profound about what must have occurred on the early Earth to ultimately give rise to the life that we're descendants of. Or maybe the answer is yes, and these rocks have the sort of tantalizing possibility of giving a positive answer, in which case we discover that even just basically in kind of the blink of an eye geologically, life was able to gain a foothold on Mars. So either way, we learn something extremely important.
And we'd like to do that before we send Mark Watney and his chums to go.
Well, they start farming potatoes and poo.
Yeah.
Richard, did you have that?
Oh yeah. What was the hardest part of the movie to make from a VFX point of view?
Two aspects. You've got the shoot and post.
Richard, do you want to chime in? Go on.
I would probably say just all the
Zero gravity stuff.
probably most
Travelling down the hallway, transitioning into the rotating spa. That shot. That was the hardest to get set up, and we had motion control cameras, motion controlled flying rigs. There was a huge amount of porpoising, we'd call it, as I'm moving down, and that every time I'd touch, I'd swing off and I'd swing back. So it was trying to minimize the amount of interaction, but look like they were interacting harder than they were. And then timing it, we only had a portion of the rotating section built. And getting the timing for Martinez to be able, because they had to rotate over so the cables could be flowing down. And getting Martinez in, and then Commander Lewis in after him was tough. Getting the choreography of that, it took about a day just to get that shot.
For that Hermes vehicle, and it is huge, right? The space in that, you would never, with current budgets, ever have so much space in your spaceship. There was like meters between each of the individual treadmills that they all had or something. But I was curious whether it was what drove that visually and how it ended up being so fabulously grand.
There was I think a collaboration with an art director who was employed by the production to sort of start doing it, and NASA and JPL, quite early doors, I think. And I think you're right, it was more grandiose on account of being a Ridley Scott movie, but I think there was a sense of kind of we were going to build it, partly for our own budget reasons. Part of the solar panels were kind of repurposed from the International Space Station and other things that we had, and so it was the overall kind of construction was kind of loosely conceived to be plausible in the sense of being made from real modules. It's just there were a lot of them, obviously. And the spinning habitation areas were, I think they were sort of, again, a bit of a contrivance, even in terms of the velocity and the and the size and so on. And of course, even that, for just to make it feel good in the edit with the speed outside the windows. I mean, it's funny, if you ask me what the hardest thing was, it could have been getting those speeds right, and kind of with all the kind of drama moments, and you had to get it just right. It's, oh no, that one's slightly wrong. Okay, fine, And so I think, it was very much a sort of, we started with something that was hopefully plausible, and then it took its own life.
Trickiest thing from our side, non-space on Earth, and it's almost like it's forgotten technology nowadays, but it's actually the stereoscopic side. This whole film was made as a 3D movie, and there was almost so much effort and attention to detail to have everything shot from. There was a conversion process, shot from two cameras, and we're trying to make sure that everything would be. So for example, in one of those things there, you had hundreds of people. Some of them were digital. They're easy because they're 3D, so you can render them from two cameras. But if you've got some of them shot and they're only one camera, then you've got to try and make sure they work in the other camera. You've got a whole crowd of people that don't exist from this eye. I don't know how much you guys know about stereoscopic, but you then have to try to cut out by something called rotoscoping every single person, and then try to project them onto two eyes so that you can watch all of this stuff in depth. And it's such a nice, even Mars, when you're watching Mars, there's so much depth and things that you had in the original one, but now all the TVs have disappeared and there's no more stereo, so you only have to watch it like this. But I remember we were spending most of our time in these stereo rooms for hours and hours saying, is it 1 pixel to the left? No, that's not just how does it look, but how does it look in depth, and would it be that correct depth? And it's all just like, that effort is just like, we can't watch it. It's a shame. Still got an old TV in my house upstairs, like the last one, you can't buy them, and it's just, all the tubes are fading, but you can still just watch the movie. But yeah, that's the trickiest bit was to get it to work in 3D.
I don't miss 3D.
Yeah, no, me neither.
Can I ask maybe Oliver a question about the Martian landscape, and that you saw in the distance some sort of sedimentary rocks you were talking about earlier. It seemed very abrupt, the way that, like, cliff-like formation. Is that plausible? Could you see how they could, thinking about the very light atmosphere, could they erode in that way? What are your thoughts?
Yeah, so it would be we'd be looking at an ancient landscape carved by glaciers and water. And there's speculation that glaciers have also sculpted the Martian landscape, possibly with actual rivers flowing underneath them. So some of the features that we take to be, fluvial river lane landscapes actually might have been subglacial themselves. So yeah, there's definitely the prospect for those incisions into the Martian surface. And on top of that, I mean, as was so beautifully shown in those kind of large-scale shots of Mars, the surface has also been gardened by impact cratering over its 4 billion years. The Earth's surface is sort of beautifully youthful and hides all of this, but Mars's surface shows its age, and especially early in the solar system's history, those first few 100 million years, planets would have been bombarded much more frequently than today. So there's this sort of external force that's kind of aging planetary landscapes. I mean, we see it obviously on the moon as well. That. And in a way, in that image I showed from Gale Crater, we see kind of on a small scale there, that same layer, stacks of sediments that you can see exposed in those kind of small cliff faces.
At the back, and then we'll come back to the front. So what was your question at the back?
It's just such a joy to hear about all this stuff with sort of films. Really enjoying it. So thank you all so much. I thought it was really interesting that you said, with gravity, NASA weren't so keen to collaborate. And I just think it's brilliant to see science and physics on film. And I think it's really important and really matters. So I guess my question is, if you are making a movie, what could we be doing as scientists to kind of make life easier for you guys to put that science on the screen? Are there things we could be doing to help with that? Thank you. Make life easier for you guys.
Wow, that's such a good question.
Yeah. Exactly.
I mean, I think it's a whole field. I'll maybe sort of go on a tangent before coming back, but one of the very interesting things about presenting some of this work at JPL was the amount of enthusiasm they had for, the example she pulled up was, I think she was a spacesuit designer, and she had been collaborating with a movie costume designer to help design the spacesuits, because I think in this case, probably not SpaceX, it was another, because around the time this movie was released, there were quite a few competing space programs. I'm sorry, I can't remember which one. I think it was an official NASA one. But she commented on how, as a spacesuit designer, she had to make a lot of arbitrary aesthetic decisions, and that actually to be guided by a kind of somebody who does this for a living and is kind of is essentially an expert communicator in the form of spacesuits, was a very valuable thing. And I think that my answer to your question broadly is that I think it pays to be plural, and that we silo ourselves in specialisms, but that actually the sort of being able to move out of those and to think and collaborate and sort of work in different areas, I think it elevates the overall. And I think that, we're always here. We love to hear from scientists who think we've got it wrong. You can always send us an email. And but likewise, I think that there's processes, and design is its own form and its own thing. It's very important, and I think that presentation of ideas in the context of design and in the context of narrative is very important. So I think those are all very worth thinking about as scientists. That would be mine.
Yeah.
What was mission control like? And did you have any dramatic moments, even clearly not as dramatic?
So I always say mission control is exactly like it is in the movies. I think for The Martian, it is exactly like it's in the movies, but our mission control was huge. And that's a question of mine to understand, was it all real, actually, or was it indeed a digital effect?
No, that was NASA propaganda. That was JPL propaganda.
It was a real set with a real giant screen, full-screen graphics.
Yeah, exactly. That was the building we were in. So they had this building over in Budapest, and it was a mixture of different rooms. There were different rooms for different sections. It's called the Whale Building, and all the graphic screens were all completely. So they're all sitting, they're all talking away, but everything up there had to be carefully planned and generated, and people pretending they're watching something, but they're not really.
But the people were all there. So it was,
Yeah, mostly, yeah, they were there. Yeah, mostly, yeah.
so that was huge. My mission control center had about 3 people in it. We have the big screens up the front. And even today for the International Space Station over at NASA, and it should say, so for the International Space Station, we have a number of control rooms around the world. There's the NASA control room, and there's 2, in fact, in the States. There's one in Canada, there's one in Europe where I worked, there's one in Russia, because the International Space Station has a Russian component, there's one in Japan near Tokyo. And even in the main control room for NASA, there is now usually maybe 4, 5, perhaps 10 people on a busy day there, so they're much smaller. But you have those big screens, and the sense when you walk into mission control, to me, it's similar to that sense when you walk into perhaps something like a cathedral, where you have this big, dark, calm space that's very beautiful because you've got all these images and you've got the people on the headsets really concentrating and solving problems. And that I thought the movie brought to life really well. And we're there round the clock all the time, planning out what the crew will do. We have the benefit of the International Space Station of being able to talk to the crew all the time, so we were not reliant on text message communication. But I have indeed had some problems. Many of them practiced, because you practice an awful lot of things going wrong before they let you loose on the real thing so that you are prepared. But it's a long story, what I won't go into now, but the thing that was most memorable to me, I was what was called the increment lead flight director. So I wasn't sitting in mission control, I was essentially managing what was going on in mission control for a period. And these things always tended to happen around Christmas, but one of the cooling pumps on the space station broke down, and there on the outside would have needed a spacewalk. That triggered off a chain of events which led to the ammonia pumps, which is the cooling systems on the outside of the space station, also being shut down. Various decisions got made, including by myself, and it led to a situation where we were not sure if the ammonia, which was cold, had frozen the water, and if water freezes, it expands. And this was in a thing called the interface heat exchanger, which is where you've got pure ammonia and water separated by just a thin set of fins for all the cooling. And the way the space station is designed through a flaw that kind of crept in 20, 30 years ago, if that interface heat exchanger were to breach, the ammonia will contaminate the entire US part of the space station, potentially killing the crew if they are exposed to ammonia, because it's lethal, and completely wiping out the whole of the space station. A little bit like what might have happened when the airlock blew and all the air rushed out. And I was quite impressed that they could fly Hermes all the way back home having done that. It turned out not to be the case, but it was there was a lot of late night discussions. We had a Christmas Eve spacewalk to go and fix something. I spent Christmas Day making sure that the space station, well, the Columbus module was in fact fine. And it was, and everybody has lived to tell the tale. But we've certainly had some moments which you go through it all and we're calm, and that's what we're trained to do. And you get to the end of it and you sort of look back and you realise it could have gone a different way and it could have been very different. But yeah, mission control is always, it's like you see in the movies. Generally the movies do it pretty well, just sometimes slightly smaller scale.
I think we've got time for 2 more questions, yeah.
Thank you. So this morning we saw how art and science, the lines are really fine now, and how amazing some of the art is within science. So this is a bit of a two-parter. For the VFX artists, what are some things that aren't currently in movies, but you might have seen in science that you think would be fun to explore within movies? And then for the scientists, what are some kind of concepts that are outside of the public eye that you'd like to see realised within Hollywood?
I'd like to see a Mars terraforming.
Martian too.
Yeah. Maybe even the next moon landing would be cool to watch, I think, if we all come together and land on moon and see what happens with that. They're supposed to be coming.
It is, and actually I think I think that will be where the two cross over, and I don't think anyone has really an idea of what is coming. So the the next moon missions are coming, they will happen. My money actually is on a moon landing within the next 3.5 years. Truly, because Trump started the Artemis program at the start of his first term, and he gave NASA the goal of landing by 2024 because that would have been the end of his second term. He had a 4-year break, but that Artemis program is happening. The Artemis 2 crew are training and getting ready for what would be a round the moon style flight. There's still work to do on the landers, but the Orion spacecraft, the European Space Agency's part of that, are built. And so we will see humans return to the moon. I'm pretty confident of that. There's a space station called the Lunar Gateway, which has been built, which is also a little bit uncertain because of what's happening with budgets over at NASA. But what I see is the public don't really wake up until they're on the front page, and nor should you, right? There's a lot of people, a bit like movies. You don't know they're happening until suddenly they're launched. No one knows they're coming until it's there. But when those missions happen, just think how iconic the Apollo missions are. We're about to do that with a whole load of visual stuff and streaming and HD and all the rest of it. And I think suddenly you will see the stuff happening on the moon and wonder that it isn't like a movie. And there are enough conspiracy theories around did Apollo happen? Just what happens when these two collide and you can't quite tell the difference. I have no idea, but we are going back to the moon and the visual effects will be real and amazing. And then I look forward to seeing what Hollywood does with it.
Just as an aside, the Delta IV that launches at the end of the movie is the first launch of Orion.
Is it really?
Yeah.
Oh, that's really nice. I didn't know that.
Yeah, for me, the kind of science is inherently creative as well. So I sort of see it, they're kind of, parallel kind of explorations in creativity, maybe with different tools and different rules to how they proceed. And I guess I have a scientific set of rules to operate by compared to the rules a director imposes or otherwise. So what I'd be really excited to see, what the science has taught us in the last 2 decades is just how unique the solar system is and just how exotic worlds are out there beyond the solar system. Planets the size of Jupiter pretty much kissing the face of their star. Planets possibly covered in vast liquid water oceans. Planets that are entirely molten when you descend below the clouds. I'd love to see a kind of exploration of these kind of exotic solar systems, planetary systems we know that are out there, and what humans would do when faced with that kind of exotic.
I think that's a very contemporary thing to want to put in. I've worked on a movie called Jupiter Ascending, which is really at the far end of the spectrum of this that kind of fantasy, but or fantastical sort of representation of space. But I know that when you're doing those, again, you're trying to ground these things in reality, and obviously the James Webb Telescope is there now. That's a relatively recent sort of. We saw it, didn't we? That was kind of the most exciting bit of the presentation at JPL, was seeing all that stuff. And I think it's just fantastic that it's going to open everybody's imaginations into sort of what.
Because the imagery that we're getting back from that as well is super inspiring.
But the two really do keep, two sides of the same coin. It is films like The Martian and all of this that get created in a way that captures people's imagination, that leads people then to places like the IOP or to say, can I be a part of this? And then we are very happy to welcome them into the industry. And I am always the sort of person who will look at this and go, oh, no, that's not quite right. And I'm terrible. I can't quite ever enjoy the movie because it's too much like work. But The Martian was one I really did enjoy. But so I really think it's great that there are people who are out there wanting to tell those stories in a way that captures everybody. And it's a wonderful film.
One thing that actually always freaks me out is you're talking about this. We're always trying to copy what the scientists do, but then there's the art. Form follows function and reverse. And I remember, sorry to admit, but I used to watch Star Trek when I was young. But you have this. You have this.
You have to be ashamed of that.
Yeah, wrong crowd. You're in the same environment as Star Trek. But no, but I was just going to say that I remember thinking, when you'd have someone Picard saying, "Computer, do this," and I was like, "That's never ever going to happen. It's so stupid." And now, my kid will be just talking to ChatGPT as if it's his normal life, and it's terrifying. I think it's actually probably more advanced than the computer you had on the Enterprise already. So what's coming next? Yeah, that's what interests me. That sometimes all these ideas that are being chucked on there that people say they're not quite right, but then the scientists actually make them right in the future from that.
Wonderful. Well, we have have gone over, but we have a question from a younger member of the audience that I think we should make time for.
How much did it cost?
Excellent question.
Great question. It would have been, it was probably the stuff we talked about being the most difficult as well, right?
Zero G stuff.
Yeah, so it was,
hallway and the rotating extension would be my guess. I don't know the actual numbers on that.
I can't remember the exact numbers, but that stuff, it can cost, let me get this, it can cost millions of dollars per minute in terms of sort of getting it through. So.
And it was a really curious ballpark, the Martian, any film. What does a film in total cost to make? Because I'm very curious to then compare that to how much it cost me to put something in space. So, yeah.
A lot less.
Say 120 million.
Million, yeah. Well, the UK Space Agency's annual exploration budget is about 70 million a year. And so that it really, for anyone who goes, how much do all these things cost? It is always to me really interesting when you start putting them in context. And I think if you would, I won't do it now, but if you ask many people, you go, space exploration is so much more expensive than what we cost, a film. But in some ways they're sometimes comparable, and neither one is right or wrong, and they are what they cost. But space exploration, I don't ever think is quite as expensive as people think it is in the grand scheme of things.
So what I'm hearing is we should make the next movie in space.
Yeah, let's do that.
Wonderful. Well, I'm afraid we've gone over, so I'm going to have to call it there. So I've just got a few thank yous to end with. So first of all, thank you again to our amazing panel. We've been really privileged today to have access to such amazing expertise, so thank you all very much for coming today. Thank you all for coming. So this was a new event. We've never done this a film festival at the Institute of Physics before. So this was the brainchild of Richard, who's on our South Central branch. So this event has been organised in partnership between volunteers on the South Central branch and also the Institute of Physics and their conferences and events team. So thank you to everybody who contributed today. We've been very grateful for everyone's help and support, particularly the technical expertise at the back of the room, especially turning off the lights. Thank you very much. He had to go upstairs and flip off the circuit board upstairs to get them to go off. So we're very grateful that you were able to do that, so we could enjoy the marvellous Martian in its all its glory. And I think that's it. So anyone else I've forgotten to say thank you to? Oh yes, we've had some sunglasses handed in as lost property, so if anyone, there we go, okay. And a happy ending there as well. So thank you very much. Enjoy the rest of your weekend and hopefully see you next year. Thank you.